Remote sensing and satellite technologies have revolutionized modern agriculture by enabling farmers and agribusinesses to gather, interpret, and use high-resolution, real-time data about their fields without ever setting foot on the farm. These digital tools offer invaluable insights into the condition of crops, soil, water availability, and environmental variables on both micro and macro scales. Remote sensing involves the use of satellites, drones, and aircrafts to capture images and data about the Earth's surface from a distance. In agriculture, these technologies are being used to monitor crop growth, pest and disease outbreaks, drought conditions, yield forecasting, and more. What is remote sensing? Remote sensing is the process of collecting data or information about an object or area from a distance, typically using satellite or aerial platforms. This includes satellites in orbit, e.g. Sentinel, Landsat, MODIS. Unmanned aerial vehicles, UAVs or drones. Manned aircrafts equipped with special cameras and sensors. These platforms carry sensors that detect and record various types of electromagnetic radiation, visible, infrared, etc., which are then processed into images or maps. Key components of remote sensing in agriculture. Sensors, devices that detect radiation or energy emitted by the Earth's surface. Types include optical sensors, thermal sensors, multispectral sensors, and hyperspectral sensors. Platforms, satellite-based, offer wide coverage, long-term monitoring, and are useful for national or regional crop assessments. Drone-based, provide high-resolution, field-level data for day-to-day decision-making. Imagery. Satellite or drone images are analyzed using software to derive vegetation indices, soil conditions, and weather patterns. Processing tools. Geographic Information Systems, GIS, AI algorithms, and data analytics platforms are used to interpret the raw data and convert it into actionable insights. Read the following document. Benefits of remote sensing in farming. Benefits and their explanation. Applications of remote sensing in agriculture. 1. Crop monitoring. Detect crop stress, growth stages, and health. Vegetation indices like NDVI, Normalized Difference Vegetation Index, help assess photosynthetic activity. 2. Yield estimation and forecasting. Analyze plant biomass and canopy structure to estimate crop yield weeks or months in advance. 3. Soil mapping satellite images identify soil texture, organic matter levels, salinity, and erosion risk. 4. Pest and disease detection. Early detection of pest and disease hotspots using thermal and multispectral imaging helps in targeted pesticide use. 5. Water resource management identify areas suffering from drought or over-irrigation. Monitor changes in water bodies and drainage patterns. 6. Land use and land cover mapping. Understand how land is used across different regions and detect changes in crop rotation or deforestation. 7. Disaster management. Evaluate damage caused by floods, droughts, hail, or fires, and inform insurance and relief planning. 8. Precision agriculture. Combine with other digital tools to apply water, fertilizers, or pesticides precisely where needed. Case studies. India, Mahalanobis. National Crop Forecast Center uses satellite-based remote sensing to estimate acreage and yield of crops like wheat, rice, and pulses. Farmers receive advisories and alerts directly through mobile apps. Nigeria, NIMET Agricultural Advisory. Nigeria's meteorological agency combines weather and satellite data to issue forecasts and disease alerts to farmers in local languages via SMS. USA, Climate Field View. a platform using drone and satellite imagery to create heat maps and zone-specific planting recommendations for corn and soybean growers. Challenges in using remote sensing cloud interference. Cloud cover limits optical satellite visibility. High costs of high-resolution imagery. Some data providers charge significant fees. Technical expertise requires skills in GIS and image analysis. Data overload. Farmers may be overwhelmed by excessive data without proper tools to interpret. Internet access. High-speed internet is needed to download and analyze high-resolution imagery. Future trends: AI and machine learning integration for automated interpretation of satellite images. Real-time dashboards, mobile apps that deliver processed data instantly to farmers. Microsatellite networks, swarms of small satellites providing daily coverage at lower costs. Blockchain for remote verification, tracking and certifying remote sensing-based interventions. I look forward to congratulating you upon completion of this course.